You've heard it a million times, right? The warnings that we're on the brink, that our cars are all going to grind to a halt because we've simply run out of fuel. But is that actually true? Are we really about to run the tank dry on oil and gas? Well, today, we're going to check the world's fuel gauge and see what it really says. So let's get right into it. How much is left? It seems like a super simple question, but believe me, the answer is anything but. It's this complex mix of geology, technology, and yeah, even economics. So to really figure it out, we're going to have to break it down piece by piece.
First things first, before we can even begin to count barrels, you gotta understand how oil and gas come out of the ground. See, they aren't in neat separate pockets. They're actually all mixed up together, stuck under incredible pressure.
Yeah, so deep underground, everything is being squeezed like crazy. This pressure literally forces natural gas to dissolve right into the liquid crude oil. But the second you bring that oil up to the surface, bam, the pressure is gone, and all that trapped gas wants to get out, and fast. Now, to handle this, the industry basically uses two main tricks: flash separation and stage separation. They're just clever ways of controlling that pressure drop so you can safely get the gas out of the oil without any, issues. The easiest way to think about this is just cracking open a can of soda. That psst sound, that's the dissolved gas, the carbonation, escaping because you just released all the pressure. It is the exact same principle with oil and gas, just on a slightly larger scale. Okay, now that we've got that down, let's get to the fun part, the big numbers. We're going to start with what we know is in the tank. This is the stuff we're absolutely confident about, the part of the equation we can count on. And the term you have to know here is proved reserves. This is not a wild guess. This is the specific amount of oil and gas that we know exists and that we can get out of the ground profitably using the technology we have right now. Those are the magic words, profitably and right now. So let's look at the numbers. Now, the data for this explainer comes from the end of 2009. Back then, BP estimated the world's proved oil reserves at a mind-boggling 1,333 billion barrels. And yes, that is billion with a B, an absolutely massive number. A number that huge is almost impossible to wrap your head around. So what did it actually mean? Well, at the rate we were using oil back in 2009, those proved reserves alone were enough to last for more than 45 years. Okay, how about natural gas? Well, in 2009, proved reserves were pegged at 6,621 trillion cubic feet. Trillion! Again, we're talking about an astronomical figure here. And to put that in perspective, it was enough gas to keep the lights on for about 63 years at the 2009 rate of consumption. So even just looking at what we knew for sure, it was clear the world wasn't about to run out the next day. But wait, proved reserves is just one chapter of the story. It's actually the most conservative, most cautious estimate, because beyond what's proven, there's this whole other world of what's possible. So it's really important to get this difference. On one hand, you have proved reserves, the stuff we found and we know we can get. On the other hand, you have undiscovered resources. These are the educated guesses about what we think we might find in places we haven't even started drilling yet. And this is where it gets really interesting. Geologists don't just give one number for this stuff. They talk in probabilities. Check out this data from the US Geological Survey. They say there's a 95% chance we'll find at least another 334 billion barrels of oil. But there's also a 5% chance we could find over 1 trillion more barrels. The most likely guess, the median, is about 607 billion. And you can see the same huge range for natural gas. It's wild. And if that wasn't enough, there's a third, kind of hidden factor called reserve growth. And this is fascinating. It basically means that even in the oil fields we've been pumping for years, we get better and better at getting the oil out. New tech comes along, or we get a better map of the underground geology, and suddenly we realize there's more in there than we thought. The field's potential literally grows over time. And this isn't some flash in the pan. As the source material points out, even though an early USGS estimate guessed this growth would stop around 2025, it's just, unreasonable to think it would just suddenly halt. We keep innovating, so this process of finding more in old places just keeps going. Okay, so we've got proved reserves, we've got undiscovered resources, and we have reserve growth. So let's throw it all in the pot, stir it up, and see what the final tally looks like for our global fuel gauge. And here is where the picture from that 2009 data really comes into focus. When you combined all the estimates for conventional oil, that's the proved, undiscovered, and growth, it gave us a projection of about 79 years of production. But then you add in the unconventional stuff, like oil sands and shale oil. That was projected to add another whopping 125 years on top. The total potential was just enormous.
The story for natural gas was pretty much the same. Projections showed about 87 years of conventional gas left. But on top of that, you have these huge unconventional sources like shale gas. And to give you an idea of how big a deal that is, by 2010, literally half of all the natural gas produced in the United States was already unconventional.
So what's the verdict? What does all this data tell us? The answer, at least back then, seemed pretty darn clear. We are not running on empty. Not even close. When you added everything up, the conclusion was that global resources of both oil and gas were abundant. And that really brings us to a final and maybe more important thought. Maybe the question we've all been asking, how much is left, was never the right question to begin with. The data suggests we're not running out. The real question, the one for our time, is probably this: what are we willing to do to get it? Because it's not a question of geology anymore, it's a question of technology, economics, and what we choose for our environment.